On the night of December 19th, something truly extraordinary is happening. As you read these words, an object from another star system is making its closest approach to Earth, about 168 million miles away. This object, traveling through space at speeds exceeding 130 km/h, has crossed an unimaginable distance across the void of interstellar space over billions of years. And tonight, it is passing by our planet for the first and last time. This is no work of fiction. This is happening right now. This moment marks a pivotal event in human history. It's not just a report about the latest developments regarding 3I Atlas, the object currently passing by Earth. Tonight, we are witnessing history unfolding. We will take you on a journey, from the initial discovery to every fascinating anomaly and remarkable coincidence that has made 3I Atlas the most captivating and controversial cosmic visitor ever encountered. By the end of this evening's story, you'll understand why some scientists believe this object could be older than our own solar system. You'll learn about the 15 perplexing anomalies surrounding it, which have stirred debates within the scientific community, similar to the debates sparked by the discovery of Oumuamua. We will also discuss its intriguing connection to a mysterious signal detected in 1977, which seems statistically improbable. Furthermore, we'll explore what happens next as 3I Atlas continues its journey toward Jupiter, heading for a rendezvous that some believe was planned. But for now, let's take a moment to truly appreciate the magnitude of what's happening tonight. At approximately 0600 Universal Time on December 19th, 3I Atlas, formerly known as C2025N1, reached its closest approach to Earth. This object, which had been silently traveling through the cosmos, is now about 270 million kilometers, or 168 million miles, away from us. For perspective, this is nearly double the distance between Earth and the Sun. Yet, this is the closest it will ever come. Think about that for a moment. An object that might have been wandering through space for 7 to 14 billion years is finally here, passing by our doorstep, only to vanish once more into the vast expanse of space. And unlike many celestial objects, it's not here to stay, collide, or deliver any simple message. It will simply sweep past, briefly touching our solar system, and continue its journey into the deep, dark void from which it came. There's a profound sadness in that, as though a ship sails past in the night, or a stranger catches your eye on a train for a fleeting moment before disappearing forever. But 3I Atlas is no ordinary stranger. Since its discovery on July 1st, it has confounded scientists and defied expectations. It has exhibited behaviors that no comet has ever shown before. Its characteristics are unlike any other known object, interstellar or otherwise, and with every passing day, it deepens the controversy and division among scientists, mirroring the debates that erupted after Oumuamua's arrival. As we speak, observatories and telescopes around the world are locked onto 3I Atlas. Although rain initially delayed observations, amateur astronomers from around the globe have contributed their findings, creating a collective image of this mysterious visitor. However, the most remarkable discoveries have come from space. Just yesterday, NASA released images captured by the Europa Clipper spacecraft. This probe, which is currently en route to Jupiter's moon Europa to search for life beneath the ice, found itself in a unique position to observe 3I Atlas. On November 6th, Europa Clipper's ultraviolet spectrograph instrument spent 7 hours observing the interstellar object from a distance of approximately 102 million miles. At this time, Earth-based observations were largely hindered by the Sun's position, making the view from Europa Clipper irreplaceable. What did it reveal? The instrument detected signatures of oxygen, hydrogen, and dust emanating from 3I Atlas. It captured a downstream view of both the dust and plasma tails of the comet, providing insights into its outgassing that would have been impossible to observe from Earth. Dr. Kurt Rutherford, the lead investigator for Europa's ultraviolet spectrograph, described this unexpected opportunity as a rare and invaluable discovery, offering a deeper understanding of the comet's composition and processes. Yet Europa Clipper was not the only spacecraft observing 3I Atlas. In late November and early December, X-ray telescopes around the world trained their sights on the comet, revealing something unprecedented. The XISM Observatory, a joint mission between NASA and the European Space Agency, spent 17 hours observing 3I Atlas from November 26th to 28th, capturing images that displayed an extraordinary halo of X-ray emissions extending approximately 250,000 miles from the comet's nucleus, nearly the distance from Earth to the Moon. This X-ray glow wasn't coming from the comet's surface itself, as comets are too cold to emit thermal X-rays. Instead, the emission resulted from a process known as charge exchange, where ions from the solar wind, such as oxygen and carbon, collide with neutral gas molecules released by the comet, capturing electrons and emitting X-rays in the process. This phenomenon has been observed in comets within our solar system, but this is the first time an interstellar comet has been observed in X-ray light. On December 3rd, the European Space Agency's XMM Newton Observatory also observed 3I Atlas for 20 hours, capturing stunning low-energy X-ray images of the comet. The resulting images showcased the comet glowing in red X-rays against the backdrop of space, surrounded by softer hues of purple and blue. This X-ray data is crucial because it can detect gases that other instruments miss, offering even more information about the comet's composition and activity. The discoveries surrounding 3I Atlas continue to intrigue scientists. It is a cosmic visitor unlike any we've ever encountered, and with each new observation, we uncover new and surprising details. What is next in store for this interstellar wanderer? Will it reveal more anomalies or offer further glimpses into the mysteries of the universe? One thing is certain, this is just the beginning of a journey that will likely continue to challenge our understanding of the cosmos. And as 3I Atlas continues its path toward Jupiter, the questions surrounding it will remain, prompting further exploration and, perhaps, deeper revelations. On the night of December 19th, a momentous event unfolds in the sky above us. As you read this, an interstellar object is making its closest approach to Earth. This object, moving at an incredible speed of over 130 km/h, is traveling across the vast expanse of space at a distance of 168 million miles from our planet. It has journeyed through the darkness of the cosmos for billions of years, and tonight, it is passing by our planet for the first time and the last time. After tonight, it will continue its journey, never to return. This isn't a scene from science fiction. It's happening right now. Tonight, we are not simply discussing the latest updates on 3I Atlas. We are witnessing history. We are here to recount a remarkable journey that stretches from this very moment back to the night everything changed. Along the way, we'll dive into every discovery, anomaly, and unexpected twist that has made 3I Atlas one of the most controversial and fascinating cosmic visitors in human history. By the end of this story, you will grasp why some scientists speculate that this object may be older than our own solar system. You'll also learn about 15 key anomalies that have divided the scientific community in a way not seen since the discovery of Oumuamua. We'll explore its mysterious link to a 1977 signal that defies statistical probability, and uncover the upcoming chapters of its journey toward Jupiter, where some believe a rendezvous was planned. But for now, let us remain in the present. In the heart of this extraordinary moment on this December night, at precisely 600 hours Universal Time. 3. I Atlas, formerly known as C2025N1, reached its closest point to Earth, approximately 270 million kilometers or 168 million miles away. For context, this is almost double the distance from Earth to the Sun, but it's as close as this interstellar traveler will ever come. Reflect on that. An object that has likely been drifting across the cosmos for 7 to 14 billion years has finally reached our doorstep, not to stay or to collide, but simply to pass by, sweep past our star and planets, and then continue its journey into the cosmic abyss. There's something deeply poignant about this fleeting moment, like a ship passing silently in the night, or a stranger catching your eye for an instant, only to disappear forever. But 3I Atlas is no ordinary stranger. Since its discovery on July 1st, 2025, it has defied every expectation, behaving in ways that no comet has ever behaved. It's displayed characteristics unlike anything we've observed in any other cosmic object, whether interstellar or otherwise, and in doing so, it has ignited a scientific firestorm that has split the astronomical community into opposing factions, each more entrenched in their views with each passing week. As 3I Atlas nears its closest approach, telescopes around the globe have turned their attention to it. Despite rain delays, amateur astronomers worldwide have captured images, contributing to a collective portrait of this enigmatic visitor. However, the most remarkable observations have come from space itself. On November 6th, 2025, NASA's Europa Clipper spacecraft, which is en route to Jupiter's moon Europa to search for life beneath its icy crust, found itself in a unique position to observe 3I Atlas. With Earth-based observations blocked by the Sun's position, Europa Clipper's ultraviolet spectrograph instrument spent 7 hours observing the comet from a distance of around 102 million miles. This vantage point allowed scientists to capture crucial data about the comet's outgassing, something that couldn't be observed from Earth. The data revealed signatures of oxygen, hydrogen, and dust streaming from the comet, as well as a detailed view of both its dust and plasma tails. Dr. Kurt Rutherford, the principal investigator for Europa's ultraviolet spectrograph, called the opportunity completely unexpected, providing a deeper understanding of 3I Atlas's composition and outgassing processes. But Europa Clipper was not the only spacecraft keeping an eye on 3I Atlas. Between November 26th and 28th, Japan's XISM Observatory, a collaboration with NASA and the European Space Agency, spent 17 hours observing the comet. What they discovered was extraordinary. A halo of X-ray emissions extending about 250,000 miles from the comet's nucleus. This X-ray glow, resulting from charge exchange between highly charged ions in the solar wind and the comet's gas molecules, is a phenomenon that has been observed in many comets within our solar system. But 3I Atlas is the first interstellar comet ever observed in X-ray light. On December Dryad, 2025, the European Space Agency's XMM Newton Observatory observed 3I Atlas for 20 hours from a distance of 175 to 177 million miles. The resulting images showed the comet glowing in low-energy X-rays, with a vivid red hue surrounded by shades of purple and blue. This X-ray data is invaluable because it detects gases that other instruments miss, allowing scientists to see a different aspect of the comet's composition and activity. Through these various observations, scientists have confirmed that 3I Atlas is actively outgassing. The Sun's heat is sublimating its ices, just like it does with comets born in our solar system. But something is different about this comet. One feature that stands out is its anti-tail. While most comets have tails that point away from the Sun, 3I Atlas displays a prominent feature pointing directly toward it. This anomaly has been visible since the first images captured by the Hubble Space Telescope in July, and it remained apparent in subsequent images taken in November. This anti-tail has puzzled scientists. According to Avi Lowe, a Harvard astrophysicist, this feature should not exist. Gas and dust particles should be pushed away from the sun by solar radiation, not form a tightly focused jet pointing sunward. Lowe has proposed several theories to explain this phenomenon, suggesting that the anti-tail may be the result of tiny ice fragments shedding from the sun-facing side of 3I Atlas, which evaporate before being pushed back by solar radiation. Another theory, published in December, ties the anti-tail to a swarm of objects lagging behind the comet due to its non-gravitational acceleration. Non-gravitational acceleration is a term that has become central to the ongoing debate surrounding 3I Atlas. It refers to motion that cannot be explained by gravity alone. This has triggered a storm of speculation. While outgassing from comets typically causes non-gravitational acceleration, which nudges the comet off its gravitational path. The peculiarities of 3I Atlas have left scientists questioning everything they thought they knew. The scientific community continues to label 3I Atlas as a comet, and NASA reaffirmed this in their November 19th press conference, citing its coma, tail, and outgassing properties. Yet, the anomalies are stacking up. There is the persistent anti-tail that shouldn't exist, the extreme negative polarization, unseen in any known comet, the unusual nickel-to-iron ratio, resembling industrial alloys rather than natural celestial materials, the comet's trajectory, which aligns with the ecliptic plane to within 5 degrees, and the fact that it arrived in the same direction as the famous WOW signal detected in 1977. These are not trivial anomalies, they are improbable occurrences that add up, challenging our understanding of what 3I Atlas truly is. Tonight, as we reach the object's closest approach to Earth, we stand at a crossroads in science. We can either accept the conventional explanation and move on, or we can delve into the questions that this cosmic enigma forces us to ask. What is 3I Atlas? Where did it come from? Why does it behave in such an unusual way? And, perhaps most haunting of all, is it simply passing through? Or is there a deeper reason for its arrival? To understand where 3I Atlas is headed, we must first look back to the beginning, to July 1st. When humanity first caught sight of its third confirmed visitor from beyond our solar system, the discovery took place at the Atlas telescope in Rio Ado, Chile, perched high in the Atacama Desert, one of the driest places on Earth, where the skies are so clear that astronomers often say you can see the universe breathe. On that night, the telescope's software flagged an anomaly, a faint smudge of light, too dim to be seen with the naked eye, moving across the constellation Serpent's Cow near the border of Sagittarius. No one at the time knew what they had found, and no one could have foreseen the remarkable journey that would follow. In the early months of 2025, the skies revealed an extraordinary visitor, a cosmic wanderer that would captivate scientists and astronomers alike. Its discovery came unexpectedly on July 1st, when telescopes at the Atlas Observatory in Chile detected a faint smudge moving against the stars in the constellation Serpent's Cow. At first, this tiny object, too dim to be seen with the naked eye, was barely noticed, but it would go on to change everything. The region of the sky where 3I Atlas was first observed is densely packed with stars, making it a particularly challenging area for detecting small objects. However, subsequent analysis of the archival data revealed that the object had actually been visible as early as June 5th. The Ziki Transient Facility at Palomar Observatory had captured it even earlier, on June 14th. But it wasn't until July 1st that astronomers confirmed its presence, and soon, excitement spread throughout the astronomical community. As they began calculating its trajectory, it became clear that this was no ordinary asteroid or comet. The velocity of 3I Atlas was unlike anything observed before, traveling at a staggering 61 kilometers per second relative to the Sun. or roughly 136 km/h. This speed was too high for it to have originated in our solar system. Ruling out any gravitational assistance from our planets, the object was interstellar in nature, traveling from another star system, and its path through the inner solar system indicated it had come from a far-off place. By the end of the first week of July, the International Astronomical Union officially designated the object 3I Atlas, with 3I marking it as the third confirmed interstellar object to be discovered. Following the 2017 discovery of Oumuamua and the 2019 identification of Borisov, the Atlas, part of the name, honored the telescope system responsible for its discovery. But the question of what exactly 3I Atlas was remained open. Initial observations suggested it could either be an asteroid or an inactive comet. But subtle hints indicated that something more complex was at play. On July 21st, the Hubble Space Telescope captured an image that would resolve the mystery. 3I Atlas was not an inactive rock. It displayed a classic coma, a halo of gas and dust streaming away from an icy nucleus, indicating active outgassing as it approached the Sun. This confirmed that the object was shedding material as it moved through the solar system. However, the Hubble image also revealed something peculiar, a feature pointing towards the Sun, not away from it. This anti-tail, as it came to be known, would become a defining characteristic of 3I Atlas and a source of ongoing intrigue. As astronomers worked to estimate the size of the object, the results were far from conclusive. Early calculations placed its diameter between 440 meters and 5 kilometers. Of vast range. If 3I Atlas was at the upper end of this estimate, it would be much larger than either Oumuamua or Borisov, making it a true giant among interstellar visitors. Some speculated that its mass could exceed 33 billion tons, roughly 1 million times more massive than Oumuamua. The discovery of 3I Atlas sparked a new line of investigation, one that ventured into the realm of galactic archaeology. By studying the object's velocity, astronomers were able to trace its journey back through space, pointing it toward the constellation Sagittarius, in the general direction of the Milky Way's center. However, it became clear that 3I Atlas had not come from the galactic core itself, but from a far older region of our galaxy. The trajectory suggested it had originated from the thick disk, a population of ancient stars that formed roughly 7 to 12 billion years ago, long before the formation of our solar system. Dr. Matthew Hopkins, an astronomer at the University of Oxford, had been developing models to predict the origins of interstellar objects. His analysis, conducted shortly after the discovery of 3I Atlas, suggested that there was a 2/3 probability that this comet was older than the solar system. If his models were correct, 3I Atlas could have formed around a star that ignited when the universe was only half its current age, drifting through interstellar space for billions of years before finally arriving at our doorstep. Adding further support to this ancient origin was the object's chemical composition. Observations made by the James Webb Space Telescope in August 2025 revealed unusually high levels of carbon dioxide relative to water, a hallmark of long-term cosmic ray bombardment that would have darkened its surface and transformed its ices over billions of years. The implications of this discovery were profound. 3I Atlas was not just a wanderer from another star system, but a relic from a much earlier era, carrying with it a record of conditions that predate our solar system, Earth, and even the Sun. However, perhaps the most curious aspect of 3I Atlas was its unexpected arrival direction. Unlike most objects in our solar system, which typically approach from the ecliptic plane, the roughly flat disk where most of the solar system's planets orbit, 3I Atlas came from the south. This was a highly unusual feature and further puzzled astronomers, leading them to question the very origins and trajectory of this ancient traveler. As the mystery surrounding 3I Atlas deepened, astronomers from around the world began to scrutinize every detail of its behavior. the object continued to defy expectations, with new discoveries adding to the growing list of anomalies. The antitail, the unusual chemical composition, and its seemingly anomalous velocity all pointed to a deeper mystery, one that challenged our understanding of what interstellar objects could be and where they come from. By late 2025, with 3I Atlas now passing closest to Earth, scientists found themselves at a crossroads. The evidence for its interstellar origins was irrefutable. But what exactly was it? Was it simply a comet from another star system? Or was there something more at play? And the biggest question of all, is 3I Atlas just passing through? Or does its trajectory and strange behavior suggest a deeper, more intentional purpose? What we know for sure is that the discovery of 3I Atlas has sparked one of the most fascinating scientific debates in recent history. And its journey is far from over. As the object continues toward its rendezvous with Jupiter, some are already speculating that this meeting might not be entirely random. What will we learn as 3I Atlas moves deeper into our solar system? And what secrets might it still be hiding? The journey of 3I Atlas is far from finished, and only time will tell what the next chapter holds. Astronomers had long speculated that most interstellar objects would approach from the direction of the solar apex, which points toward the Sun's motion relative to nearby stars in the northern celestial hemisphere, near the constellation Hercules. However, 3I Atlas defied these expectations by coming from nearly the opposite direction, from the southern sky near the galactic center, specifically from Sagittarius. This unexpected origin made it harder to detect and challenged prevailing assumptions about the behavior of interstellar objects. Equally intriguing was the object's remarkable speed. 3I Atlas was traveling faster than either Oumuamua or Borisov. But this high velocity aligned with predictions for objects originating from the thick disk population of our galaxy. It was a velocity one might expect from an ancient wanderer, subjected to gravitational encounters with other stars over billions of years. In the first few weeks following its discovery, there was hope that astronomers might trace its path back to its original parent star. Researchers combed through the Gaia database, which contains detailed positions and velocities of billions of stars in our galaxy. A team led by Yang Guo found evidence that 3I Atlas had passed within about 3 light years, roughly 1 parsec of 25 known stars over the past 10 million years. However, 10 million years is practically nothing on cosmic timescales. In truth, 3I Atlas had likely been traveling for billions of years. Its trajectory scrambled by countless stellar encounters. The object's origins were lost to time. We will never know the exact star that birthed it. As the months progressed, astronomers intensified their observational efforts. Ground-based telescopes from around the world focused their optics on the interstellar visitor, while space telescopes carved out precious observing time. By August 6th, 2025, the James Webb Space Telescope observed 3I Atlas using its near-infrared spectrograph. The data revealed unexpected signatures of carbon dioxide, carbon monoxide, water ice, and a compound called carbonyl sulfide. Of particular note was the unusually high carbon dioxide to water ratio, which was consistent with the object's ancient origin. Billions of years of cosmic ray bombardment would have caused carbon monoxide ice to convert into carbon dioxide, supporting the idea that 3I Atlas was much older than typical comets in our solar system. However, it wasn't just the chemical composition that puzzled scientists. Webb's spectroscopic observations also revealed the presence of atomic nickel in the coma of 3I Atlas. While nickel had been found in solar system comets before, the ratio of nickel to iron in this comet was completely unprecedented. Normally, nickel and iron appear together in predictable proportions, but in 3I Atlas, the nickel content dominated. This anomaly drew the attention of Avi Low, a Harvard astrophysicist, who had previously raised speculation about Oumuamua being an alien artifact. Low suggested that the unusual nickel-to-iron ratio in 3I Atlas might be the result of artificial processing, possibly similar to industrial processes on Earth used to refine nickel. Although he stopped short of making definitive claims, he added this new observation to the growing list of oddities surrounding the object. The mainstream scientific community, however, pushed back. They offered natural explanations for the strange metal ratios, suggesting that the parent star of 3I Atlas might have been particularly low in iron relative to nickel, or that some unknown process during the comet's formation had concentrated the nickel. With the data still limited and the uncertainties large, most experts maintained that extraordinary claims required extraordinary evidence. But the anomalies continued to mount. By the time 3I Atlas passed behind the Sun in late October 2025, heading toward its perihelion, the list of puzzling observations had grown long enough to fuel a controversy that had yet to subside. Astronomers had their first extended look at a visitor from another star, and what they saw was deeply strange. An ancient wanderer, possibly older than our own world, shedding its primordial ices into the warmth of a foreign sun, carrying secrets we were only beginning to decode. The real surprises, however, were still to come. As 3I Atlas rounded the Sun and reappeared into view, it displayed behavior that stretched the definition of cometary activity. Jets pointed in the wrong direction, polarization patterns that had never been observed before, and a trajectory so perfectly aligned that it seemed almost too coincidental to be random. As the autumn of 2025 unfolded, more questions arose about this ancient traveler from the thick disk of the Milky Way. The object had been journeying through space for an astounding 7 billion years, since before our solar system, and likely even before the birth of Earth. This time span seemed almost unimaginable, not just 7 billion miles, but 7 billion years. A duration that began long before our Sun even existed. When 3I Atlas first coalesced in the gas and dust around its parent star, Earth and our Sun were not yet born. The atoms that would eventually form our bodies were still scattered across the galaxy, locked in stars that hadn't exploded yet, or drifting in the void between stellar nurseries. The universe was still a young place. Galaxies were still merging, and the Milky Way was in a more chaotic state than it is today. This small body of ice, rock, and metal might have orbited its star for millions or even billions of years. It witnessed events in its distant home system, events we will never know before being ejected into interstellar space. Whether it was a gravitational disturbance, the migration of giant planets, or a close encounter with another star that flung it into the cosmos, 3I Atlas became a cosmic orphan. It accelerated to escape velocity and drifted through the galaxy. A frozen wanderer, passing countless stars, witnessing the birth and death of solar systems, carrying within it a record of conditions that existed before Earth, before the Sun, and before anything we know now. As it continues its journey, we're left to wonder, what will we learn about 3I Atlas as it continues its trek through our solar system? How much of its ancient history will we uncover? And what mysteries will it continue to reveal about the origins of our galaxy and the universe itself? One thing is certain, the story of 3I Atlas has only just begun. As it moves closer to Jupiter, scientists around the world will continue to analyze its every behavior, searching for answers to questions that have been posed by this ancient traveler from the stars. The journey of 3I Atlas is far from over, and what we learn along the way may change our understanding of the cosmos forever. Interstellar space, while not truly empty, is incredibly sparse. The density of matter in this vast region is approximately 1 atom per cubic centimeter. To put that in perspective, the air you're breathing right now contains around 25 quintillion molecules per cubic centimeter. In other words, the void between the stars is a vacuum far more perfect than anything we can create in our laboratories. Through this near-nothingness, 3I Atlas has drifted. The temperature in interstellar space drops to just a few degrees above absolute zero, causing the surface ices on 3I Atlas, which may have been volatile when the object was young, to freeze solid and remain frozen for billions of years. Cosmic rays, the high-energy particles that permeate interstellar space, continuously bombard the surface of the object, slowly transforming its chemistry and creating a thick, processed crust. Occasionally, 3I Atlas would pass near another star, not close enough to be captured, but near enough to feel a gravitational pull. Each such encounter would slightly alter its trajectory, much like a billiard ball bouncing off a cushion, over billions of years. These subtle changes accumulated, scrambling its original path so thoroughly that tracing it back to its point of origin became nearly impossible. Using the Gaia Space Observatory's data, which has mapped the positions and motions of nearly 2 billion stars in our galaxy, researchers sought to find any star that 3I Atlas might have passed near in the past 10 million years. They identified 25 candidates, stars that came within about 3 light-years of the object's reconstructed path. However, this time frame represents only a tiny fraction of the object's total journey. If 3I Atlas is truly 7 billion years old, then 10 million years amounts to only 7/100th of its lifetime. It's akin to trying to determine where a person was born by examining only the last 2 weeks of their century-long life. The information simply isn't there. While we cannot know the precise origin of 3I Atlas, we can glean some important insights about the environment in which it was formed. The key to this lies in the object's velocity through the galaxy. Astronomers describe stellar and object motions using 3 components: U, V, and W. U measures motion toward or away from the galactic center. V measures motion along the direction of galactic rotation, and W measures motion perpendicular to the galactic plane. Most stars near the Sun have relatively small W velocities, gently bobbing up and down through the thin disk of the galaxy. However, 3I Atlas arrived with a W velocity of +18, 5 kilometers per second relative to the Sun, an unusually high figure. This elevated vertical velocity is characteristic of the thick disk population stars, and presumably the debris around them, that follow tilted orbits oscillating above and below the main galactic plane. Importantly, the thick disk is ancient, with stars that formed early in the Milky Way's history, between 7 and 12 billion years ago. This suggests that 3I Atlas originated from an ancient star system that is likely older than our solar system. The object itself would have to be at least as old as that star system, and possibly older, depending on how long it drifted before being ejected. Matthew Hopkins, an astronomer at the University of Oxford, developed a statistical model called the Otto-Oxford model to estimate the ages of interstellar objects based on their trajectories. When applied to 3I Atlas, the model suggested a most probable age range of 6 to 14 billion years, with a 2/3 probability that the object predates our solar system. Other analyses have pushed this estimate even further. A team led by Xavier Perez Couto at the University of Aruna in Spain used simulations involving more than 13 million stars to trace 3I Atlas's path, suggesting the object could be around 10 billion years old. To put this age in context, 10 billion years ago the universe was only 8 billion years old, less than 30% of its current age. The cosmic microwave background radiation, the afterglow of the Big Bang, was just slightly cooler than it is today. But the universe looked vastly different. Large-scale structures were still forming, and many of the galaxies we observe now had not yet taken their present shapes. In the Milky Way, the thick disk was still actively forming, with stars being born at an incredible rate, enriching the interstellar medium with the heavy elements forged in their cores and scattered by supernovae. The conditions at that time were ideal for the formation of planetary systems, although these early systems would have been quite different from our own, made from material with lower concentrations of the heaviest elements. It is possible that 3I Atlas is a remnant from one of these primordial systems. It could be a frozen time capsule, preserving in its ancient ices a chemical record of conditions that existed before Earth. before the Sun, and before anything we know. The chemistry of 3I Atlas, as observed by the James Webb Space Telescope, supports this ancient origin. The object shows an unusually high ratio of carbon dioxide to water compared to most solar system comets. This could be explained by cosmic ray bombardment over billions of years. Incoming cosmic rays would have slowly transformed carbon monoxide ice into carbon dioxide, creating a distinctive chemical signature of extreme age. The surface of 3I Atlas also exhibits evidence of irradiation, with reddish hues in some wavelengths, accompanied by the presence of tholins, complex organic molecules that form when simple ices are bombarded by radiation over long periods. These tholins are common in many objects in the outer solar system, but their specific composition and distribution in 3I Atlas suggest billions of years of cosmic ray exposure. There is something almost sacred in this discovery. We are looking at material that has remained essentially unchanged since before our Sun ignited. The atoms in 3I Atlas were assembled around a star in a foreign system under conditions we can only imagine. They have traveled distances so vast that the object might have gone millions of years between encounters with even a single stray atom. And now, this ancient traveler has entered our solar system, shedding some of its primordial material into the warmth of our Sun and revealing secrets it has kept for longer than Earth has existed. But the age of 3I Atlas raises more than just awe. It also prompts significant questions about the object's contents. After 10 billion years of drifting, even extraordinarily unlikely events become possible. 3I Atlas might have passed through molecular clouds, regions of space where gas and dust concentrate, or even close enough to other planetary systems to pick up material ejected from those worlds. What if 3I Atlas carries traces from multiple stellar systems? What if its ices contain isotopic signatures from different environments, different epochs, and different regions of the galaxy? While we don't yet have detailed data on the object's composition, researchers are tantalized by the possibility that 3I Atlas could hold a geological sample from across the Milky Way, a time capsule that carries the secrets of a journey across space and time. This mystery goes beyond geology. The extreme age of 3I Atlas invites even deeper questions about the origins and dynamics of the Milky Way itself. How did this object travel through the galaxy? What stellar encounters shaped its journey? What lessons might we learn from this ancient visitor? And how might it change our understanding of the history of the cosmos? While the object's precise origins remain elusive, its presence in our solar system forces us to confront our assumptions about the universe. And in doing so, it invites us to continue searching for answers that may be more wondrous than we can yet imagine. If 3I Atlas truly has an age spanning between 7 to 14 billion years, then it formed during an era when the universe had already existed for billions of years. This was a time when multiple generations of stars had already lived and died, enriching the cosmos with heavier elements. It was a time when rocky planets could have formed, and potentially, when life itself might have arisen. Despite the fascinating possibilities, we have no concrete evidence that 3I Atlas is anything other than a natural comet. The mainstream scientific consensus firmly believes that it is, in fact, a comet, though one that exhibits certain unusual behaviors. But scientists like Avi Lowe and others suggest we should keep an open mind. If intelligent life arose elsewhere in the galaxy billions of years ago, such civilizations could have had ample time to explore, expand, and perhaps even send probes to distant star systems. These probes might be indistinguishable from natural objects at first glance. Lowe remains cautious, estimating only a 40% chance that 3I Atlas is artificial, leaving the majority of possibilities for its natural origins. However, Lowe insists that the object's anomalies merit serious investigation, and dismissing the possibility of artificiality without a thorough examination would be unscientific. Despite Lowe's arguments, the mainstream scientific community has largely rejected this perspective. Professor Jason Wright from Penn State University has written detailed rebuttals of Lowe's claims. asserting that each anomaly can be explained by natural processes or misinterpretations of data. The scientific establishment continues to stand by the idea that 3I Atlas is a comet, albeit one exhibiting odd characteristics. The debate, however, will not be decided by rhetoric, it will be determined by data. While 3I Atlas remains within the range of our telescopes, each new observation brings us closer to understanding the true nature of this ancient visitor. What is clear is this, regardless of its origins. 3I Atlas represents something extraordinary, an object potentially older than Earth itself, carrying ices that formed before our Sun ignited. Shaped by billions of years of wandering through the cosmos, it is a messenger from the distant past, from a time when the foundations of everything we see around us were still being formed. In a few years, 3I Atlas will fade from view, too distant and too faint for even our most powerful telescopes to track. It will continue its journey, sailing out toward the stars, carrying its ancient secrets into another eternity of silence and cold. But for now, for this brief window, we have the chance to study it, to analyze its light, model its trajectory, and piece together fragments of its story that are accessible to our instruments. Each observation is precious, each data point a word in a message that has taken billions of years to arrive. This ancient traveler is here, and what it might reveal depends on how carefully we look and how open we remain to possibilities we've yet to imagine. The 15 anomalies that have defied every explanation illustrate how science progresses. When observations contradict expectations, when data fails to fit into existing theories, that is when the most intriguing questions arise. 3I Atlas has presented us with more anomalies than any other comet in recent memory. By some counts, the list has expanded to 15 distinct features that challenge conventional explanations. Whether these anomalies suggest something truly exotic or reflect our incomplete understanding of interstellar comets remains the central debate among astronomers. Let's take a look at each anomaly, systematically examining what has been observed, why it is considered unusual, and the possible explanations that have been proposed. The first anomaly concerns the trajectory of 3I Atlas. This object follows a retrograde orbit, meaning it is traveling in the opposite direction of the planets as they orbit the Sun. While retrograde orbits are not uncommon, about half of all comets from the outer solar system have such orbits. The specific orientation of 3I Atlas is striking. Its orbital plane is aligned with the ecliptic, the plane in which Earth and the other planets orbit, to within just 5 degrees. This is a rare alignment, with a probability of occurring by chance of roughly 0, or about 1 inch 500. Why would an interstellar object just happen to arrive aligned with our planetary plane? Avi Loeb has suggested that this could indicate a deliberately designed trajectory, perhaps chosen to facilitate observation of the planets or interaction with the inner solar system. Critics, however, argue that with only 3 interstellar objects to study, we have too few data points to make definitive conclusions. Perhaps we simply got lucky, or maybe our detection methods bias us toward finding objects with certain orbital orientations. The second anomaly involves the timing of 3I Atlas's arrival. The object's trajectory brought it close to multiple planets, while simultaneously rendering it unobservable from Earth during its closest approach to the Sun. 3I Atlas passed within 29 million km of Mars in early October, close enough for Mars orbiters to capture detailed observations. It will also approach Jupiter within 54 million km in March 2026. However, when 3I Atlas reached perihelion on October 29, it was hidden behind the Sun from Earth's perspective. Solar conjunction, which occurred just 8 days before perihelion, blocked our view during the most active phase of the comet's journey. The probability of such a configuration occurring randomly has been calculated at less than 0. While this appears almost too perfect to be coincidental, critics point out that any specific configuration of events has a low probability when calculated after the fact. If 3I Atlas had arrived at a different time, we could have calculated how unlikely that timing was as well. Without prior prediction, these probability arguments lose much of their impact. The third anomaly concerns the mass of 3I Atlas. By interstellar object standards, it is enormous. Its nucleus may be up to 5-6 kilometers across, with a mass potentially exceeding 33 billion tons. This would make it roughly 1 million times more massive than Oumuamua and 1,000 times more massive than Borisov. The two previous interstellar visitors, such massive objects should be far rarer than smaller ones, and the laws of planetary formation suggest that star systems should eject much more small debris than large debris. Finding such a giant among our third interstellar discovery is statistically surprising. One possible explanation is that larger objects are easier to detect. Our surveys are biased toward finding larger, brighter objects. So, while small interstellar visitors likely outnumber the large ones, we may simply be discovering the giants due to our detection methods. The fourth anomaly involves the chemical composition of 3I Atlas. As noted earlier, the coma of the object contains an unusual abundance of nickel compared to iron. In natural settings, these elements typically appear in predictable ratios, reflecting their cosmic abundances. However, 3I Atlas shows a nickel-to-iron ratio resembling industrially processed nickel alloys. This anomaly has led some researchers, including Avi Low, to speculate that the nickel may have been artificially refined. The carbonyl process used in industrial nickel production separates nickel from iron chemically rather than physically. Could this be evidence of artificial processing? Mainstream researchers remain skeptical, suggesting that the parent star of 3I Atlas may have had unusual elemental abundances, or some unknown process during the comet's formation could have concentrated nickel preferentially. The uncertainties are large, and more observations would be needed to confirm whether this anomaly is real or just a measurement artifact. The fifth anomaly involves the anti-tail, a feature pointing toward the sun, which shouldn't exist. Most comets develop tails that point away from the sun, propelled by solar radiation pressure and the solar wind. However, 3I Atlas exhibits an intriguing feature, a prominent anti-tail, a jet of material pointing directly toward the sun. This anomaly has persisted from the first Hubble observations in July and continues to be visible as the comet moves through space. The jet extends tightly collimated, reaching up to 500,000 kilometers, within just 8 degrees of the solar direction. This feature is puzzling because typical outgassing models would predict that the material should spread more diffusely as it leaves the comet's nucleus, not form a tightly confined sunward jet. Avi Low and Eric Cato have proposed that the anti-tail could be composed of tiny ice particles shed from the sun-facing side of 3I Atlas. These particles would sublimate before solar radiation could push them outward, creating a transient sunward stream. Another possibility suggests that the anti-tail could result from a swarm of objects lagging behind the nucleus due to non-gravitational acceleration. Other researchers have pointed out that anti-tails can form in solar system comets under specific geometric conditions, such as when Earth crosses the comet's orbital plane. However, the persistent nature of 3I Atlas's anti-tail, observable across different viewing geometries, complicates this explanation. The sixth anomaly pertains to the rotation axis of 3I Atlas. Recent observations have shown that its rotation axis is aligned within 8 degrees of the sunward direction. This alignment is unusual because, typically, a comet's rotation axis should point toward the sun only at one point in its orbit. As the comet orbits the sun, the solar direction changes, but the rotation axis remains fixed in space. Yet, 3I Atlas appears to maintain this alignment even as its orbit changes, which is highly improbable. Low calculates that the probability of this alignment occurring by chance is just 0. Wu. This unique configuration raises additional questions about the comet's behavior and origins. The seventh anomaly involves polarization. Light from 3I Atlas exhibits extreme negative polarization, an observation unprecedented in all known comets, including Borisov. Polarization refers to how light waves oscillate, and the polarization of scattered light depends on the properties of the scattering material. The extreme polarization observed in 3I Atlas suggests that its dust particles have unusual shapes, sizes, or compositions. This might be related to the anti-tail, as unusual particle properties could also explain why material is streaming toward the Sun rather than away from it. No satisfactory natural explanation has yet been provided for this anomaly, and it remains one of the most puzzling aspects of the object's behavior. The eighth anomaly concerns carbon chain depletion. Spectroscopic data has revealed that 3I Atlas is notably depleted in carbon chain molecules like C2 and C3, which are typically formed when carbon-containing ices break down under solar radiation. These molecules are responsible for the characteristic green glow often seen in comets. Early observations of 3I Atlas showed it to be reddish, rather than the expected green, consistent with the depletion of carbon chains. However, later images showed the comet turning green, suggesting that C2 molecules were finally being produced as deeper, less processed ices were exposed. This color change became a focal point for debate, with some researchers cautioning that this could simply reflect normal cometary evolution. The ninth anomaly revolves around the water abundance. 3I Atlas seems to have an unusually low water content compared to carbon dioxide. This ratio, as measured by the James Webb Space Telescope and other instruments, is significantly different from typical solar system comets. The elevated CO2 levels could result from cosmic ray processing over billions of years, which would convert carbon monoxide ice into carbon dioxide. Some researchers have questioned whether additional unknown processes might also be contributing to this unusual composition. The 10th anomaly relates to the perihelion distance. 3I Atlas passed closest to the Sun at a distance of about 1.36 astronomical units, just inside the orbit of Mars. This relatively close approach triggered significant outgassing and activity, as expected for any icy body subjected to solar heating. However, what's unusual is how this perihelion distance fits with the object's trajectory. The hyperbolic orbit of 3I Atlas, shaped by its incoming velocity and direction, leads to this specific perihelion distance, which allows for maximum interaction with the inner solar system while avoiding excessive heating that could destroy a more fragile object. Some argue that this represents fine-tuning, while others suggest it may simply be the outcome of random orbital parameters. The 11th anomaly is non-gravitational acceleration. As mentioned earlier, 3I Atlas displays motion that cannot be explained by gravity alone. Something seems to be pushing the object, altering its trajectory in ways that gravitational models fail to predict. For most comets, this non-gravitational acceleration is attributed to outgassing. Jets of material erupting from the comet's surface act like tiny rocket engines, nudging the comet off course. The magnitude and direction of this thrust depend on which parts of the surface are active and how much material is being ejected. NASA's Jet Propulsion Laboratory has been measuring this non-gravitational acceleration over time, and the values have evolved as models are refined. This anomaly adds to the growing list of unexplained features. The 12th anomaly concerns the gravitational influence of Jupiter. When the trajectory of 3I Atlas was projected forward, researchers made a remarkable discovery. The object's closest approach to Jupiter in March 2026 will bring it to within approximately 53.4 million km of the giant planet, a distance almost exactly equal to Jupiter's Hill radius, the sphere of gravitational influence within which objects can potentially orbit the planet. This proximity to Jupiter's Hill radius raises further questions about how 3I Atlas might interact with Jupiter's gravity during its flyby. This event will likely add another layer of complexity to an already enigmatic journey. As astronomers continue to monitor 3I Atlas, they are faced with a wealth of anomalies, each contributing to the growing mystery of this ancient object. The object continues to defy conventional explanations, sparking debates and raising fundamental questions about the nature of comets, interstellar objects, and even the possibility of extraterrestrial intelligence. With each new observation, we come closer to understanding what 3I Atlas is, where it came from, and why it behaves so unusually. The answers to these questions may have profound implications for our understanding of the universe and the history of our own solar system. As the 3I Atlas comet nears its closest approach to Jupiter in March 2026, an extraordinary discovery has emerged from an even earlier anomaly: the alignment of its trajectory with the Hill radius of Jupiter. The Hill radius is the region within which an object is gravitationally bound to a planet. For Jupiter, this radius is about 53.5 million km, a value that is strikingly close to the object's predicted path. Avi Low, in his analysis, has calculated the probability of such an alignment occurring by chance to be less than 0.5, making it one of the most statistically remarkable coincidences in the study of interstellar objects. This precise alignment raises fascinating possibilities. If 3I Atlas were to release small objects or debris as it passed through this region, those objects could potentially enter orbit around Jupiter, settling into stable positions near the Hill sphere boundary, where the gravitational forces are balanced. The prospect that 3I Atlas might be aiming for Jupiter or deploying something as it passes is a question that most astronomers would dismiss as speculative. However, Low argues that the coincidence is simply too remarkable to ignore, suggesting that further observation is warranted. The 13th anomaly revolves around the object's brightness evolution. As expected, 3I Atlas brightened as it approached the Sun. But the pattern of brightening didn't perfectly match predictions based on solar system comets. There were episodes of rapid brightening, indicating outburst events followed by quieter periods. This variability in brightness is typical of comets. But the speed and frequency of these outbursts remain an anomaly that requires deeper understanding. The 14th anomaly is related to the alignment of 3I Atlas's rotation axis, which is uniquely oriented within 8 degrees of the sunward direction. Comets typically experience changes in their rotation axis as they orbit the Sun. But 3I Atlas appears to maintain this unusual alignment despite the evolution of its orbit. The probability of such an alignment occurring by chance is only about 0.5, making this another rare feature of the object. The 15th anomaly, perhaps the most captivating, concerns the potential link between 3I Atlas and the famous WOW signal detected in 1977. This connection is so improbable yet tantalizing that it has generated significant interest among astronomers. The WOW signal, detected by the Big Ear radio telescope at Ohio State University, was a brief burst of radio waves that lasted 72 seconds. Originating from the direction of the constellation Sagittarius, the frequency of the signal 1,420 MHz corresponds to the hydrogen line, a natural emission frequency that many scientists believe could be used by extraterrestrial civilizations as a universal communication channel. For decades, the WOW signal remained unexplained, and subsequent searches for it in the same region of the sky have yielded no results. However, in September 2025, Avi Low traced the trajectory of 3I Atlas backward in time and discovered something astonishing on August 15th. The object was approximately 600 astronomical units from the Sun, about 600 times the Earth's distance from the Sun, traveling through interstellar space in the same direction as the WOW signal's origin. The alignment between the arrival direction of 3I Atlas and the WOW signal was a striking 9 degrees. The statistical probability of this alignment is roughly 0.5, or about 1 inch 167. While coincidences of this magnitude can occur in astronomy, when combined with the other anomalies associated with 3I Atlas, the likelihood of such an extraordinary coincidence increases. Could the WOW signal have come from 3I Atlas? Low's hypothesis, although bold, is based on a plausible scenario. At the time the signal was detected, The object would have been in the right location and at the right distance, with the potential for a transmitter on board to produce the signal's intensity. For this theory to hold, 3I Atlas would need to harbor technology capable of generating a powerful signal somewhere between 0.5 to 2 gigawatts, roughly the output of a nuclear reactor. This amount of energy is not far beyond what we are capable of producing ourselves. The frequency of 1,420 MHz also fits perfectly into the context of an extraterrestrial probe, as any civilization capable of interstellar travel would likely use this frequency to communicate or scan for signs of life in other systems. Taken together, these anomalies ranging from the strange behavior of the comet's tail, its unusual rotation, and its unexpected trajectory, to its apparent connection to the 1,977 WOW signal raise profound questions about what 3I Atlas really is. Is it simply a natural comet? Or could it be something far more complex, something perhaps shaped by intelligent forces, designed to travel across the stars, carrying information or even messages from another civilization? As 3I Atlas continues its journey through our solar system, the scientific community remains divided, with some firmly supporting the natural comet theory, while others, like Lowe, urge caution and a more open-minded approach. The mystery of 3I Atlas is far from solved, but each new observation takes us a step closer to understanding this ancient interstellar visitor and its enigmatic origins. What we do know for sure is that this is a moment in history that will continue to captivate astronomers and laypeople alike, offering a glimpse into the deeper mysteries of the cosmos. On October 3rd, Liangtianling Arshiwu, a remarkable event occurred in the Martian skies. An interstellar object, 3I Atlas, passed within a mere 29 million km of Mars, marking the closest planetary encounter during its journey through the inner solar system. This rare occurrence allowed for detailed observations from Mars's orbit, with several Martian orbiters capturing valuable data. It was a moment that would deepen the mystery surrounding the object and its behavior. The encounter with Mars was significant not only for the opportunity it provided to study the object up close, but also for what it revealed about the comet's trajectory and velocity. As 3I Atlas passed through the inner solar system, it continued to exhibit strange and puzzling features. Its high velocity at roughly 136.0 miles per hour, 61 kilometers per second, was consistent with an object originating from outside our solar system. Yet its behavior, including its outgassing patterns and the formation of a peculiar anti-tail, defied conventional explanations for cometary activity. In the months following the close approach to Mars, the object's trajectory brought it closer to Jupiter. 3I Atlas is set to pass within 54 million km of the giant planet in March 2026. Another key point in its journey that continues to intrigue astronomers. The comet's path has sparked intense debate within the scientific community, with some questioning whether it is simply a natural comet or if there might be something far more extraordinary behind its unusual characteristics. As this interstellar visitor made its way toward its closest approach to the Sun, astronomers across the world kept a watchful eye, hoping to gather more data to answer the many questions surrounding its origin, behavior, and implications. In particular, there were those in the scientific community, including Avi Lowe, who have suggested that 3I Atlas may not be entirely natural, hinting at a connection to the famous WOW signal from 1977. The WOW signal, a mysterious radio burst detected by the Big Ear radio telescope nearly 50 years ago, has remained one of the most intriguing unexplained phenomena in the history of SETI. Search for extraterrestrial intelligence. In August, Omianoa Sute Shapta Zech, Shapta, astronomer Jerry Amon recorded the signal, which lasted 72 seconds and arrived at a frequency of 1,420 MHz, the hydrogen line. This frequency is considered a prime candidate for interstellar communication, leading many to speculate that the signal might have come from an extraterrestrial source. Yet, despite repeated efforts to detect the signal again, no further transmissions were received, leaving the origin of the signal an enduring mystery. In September 2025, Lowe made a groundbreaking observation. By tracing the trajectory of 3I Atlas backward in time, he calculated that on the night the WOW signal was detected, the comet was located approximately 600 astronomical units from the Sun, about 600 times the distance from Earth to the Sun. Its position in the sky was also strikingly close to the origin of the WOW signal. The probability of such a coincidence is small, around 0. Bifangelio, or 1 inch 167. But the alignment between the two events is enough to prompt serious consideration. Could the WOW signal have been transmitted by 3I Atlas, or is this simply an extraordinary coincidence? As this theory gains traction, Lowe continues to advocate for further study of 3I Atlas, particularly around the hydrogen line frequency. If the comet were to emit even a faint signal at 1,420 MHz, it would dramatically revive the WOW signal hypothesis. However, despite this potential, no such signal has yet been detected, while the connection between 3I Atlas and the WOW signal remains speculative. The implications are profound. If 3I Atlas is indeed linked to the mysterious transmission from 1977, it would suggest that the object is not merely an interstellar comet, but a probe or beacon sent by an intelligent civilization, possibly over 48 years ago. This would be the confirmation of extraterrestrial intelligence, something that would change our understanding of life in the universe forever. But even without definitive proof, 3I Atlas remains a cosmic enigma. Whether its origin is natural or artificial, the data gathered so far suggests it is an object of extraordinary age and complexity. With each passing observation, we uncover more details about its composition, trajectory, and behavior. As we continue to study this ancient traveler, we may not only learn more about the comet itself, but about the broader mysteries of the galaxy and our place within it. Whether the connection to the WOW signal turns out to be true or not, 3I Atlas stands as one of the most intriguing objects to ever pass through our solar system. It challenges our understanding of the cosmos, posing questions that will likely take decades, if not longer, to fully answer. And as it continues its journey into the depths of space, carrying with it secrets from another time and place, we are left with one simple truth: the universe is vast, strange, and full of mysteries waiting to be uncovered. We can only continue to watch, listen, and ask the questions that keep driving us forward in our quest for knowledge. At a distance of 29 million kilometers, roughly 1/5 the average separation between Earth and Mars, 3I Atlas passed close enough to Mars for detailed observations. This proximity allowed for gravitational deflection, subtly altering the object's trajectory. More importantly, it presented an opportunity for robotic eyes to closely monitor any unusual behavior. And they did, over the weeks surrounding the Mars flyby. An unprecedented coordination of spacecraft focused on this interstellar visitor. The European Space Agency's Mars orbiters, Mars Express and ExoMars Trace Gas Orbiter TGO, both received commands to observe 3I Atlas during its closest approach. The TGO, equipped with the high-resolution camera CAS's instrument, was directed toward the comet. The images captured by TGO became the closest ever obtained of an interstellar object. While 3I Atlas appeared as a fuzzy blob, the coma surrounding the nucleus and jets and tails were clearly visible, offering a glimpse into the comet's structure. This was the first time interstellar comet observations had been made from an interplanetary vantage point. Mars Express also participated with its high-resolution stereo camera. Although less successful than TGO, still, its attempt contributed to the global effort to characterize 3I Atlas. NASA's Mars Reconnaissance Orbiter, MRO, with its high-rise imaging system, joined in. On October 2nd, MRO captured images from about 19 million miles away, showing the comet as a bright smear in the vastness of space. This photograph helped refine calculations about its trajectory. However, some of the data from these missions was delayed due to technical and bureaucratic hurdles at NASA, sparking speculation about potential cover-ups. In reality, these delays were due to logistical issues, and the data was eventually shared and incorporated into the scientific record. International collaboration on this object extended to the Chinese National Space Administration (CNSA) as well, with the Tianwen-1 orbiter capturing images of 3I Atlas. The Perseverance rover on Mars also contributed. Positioned in Jezero crater, it had a unique vantage point of the comet from the Martian surface, despite Mars's thin atmosphere, which causes scattered light and can obscure faint objects. Perseverance managed to capture images of the comet, an incredible moment of human ingenuity, where a rover on another planet photographed a visitor from another star. The Mars flyby was critical not just for refining 3I Atlas's trajectory, but also for measuring how much the comet's path was influenced by gravity. By tracking its deflection around Mars, scientists could assess its mass and confirm that non-gravitational factors, like outgassing, were influencing its motion. This provided further evidence of the comet's non-gravitational acceleration, a key anomaly that's been central to the controversy surrounding its nature. As researchers modeled the comet's trajectory, they noticed something remarkable when projected forward to its March 2026 encounter with Jupiter. The predicted closest approach distance aligned almost exactly with Jupiter's Hill radius, the region within which objects can potentially orbit the planet. This precise match has an improbability of less than 0.5, raising further questions about the comet's path and what might happen as it passes Jupiter. Could 3I Atlas be aiming for the planet, perhaps even releasing objects as it passes beyond Mars? More spacecraft joined the observation effort. NASA's MAVEN mission, which studies the Martian atmosphere, detected hydrogen atoms surrounding the comet, confirming water molecules were being dissociated by solar radiation. The Psyche spacecraft, en route to the metal asteroid of the same name, passed about 45 million kilometers from 3I Atlas in early September 2025. While not designed to study comets, it contributed to the growing catalogue of images. Similarly, the Jupiter Icy Moons Explorer JUICE mission, launched by the European Space Agency, also observed the comet, offering a fresh perspective. Between November 2nd and 25th, JUICE's cameras and spectrometers captured images showing the coma and tails in great detail, complementing data from both Earth-based and Mars-based observations. 3I Atlas's behavior and the coordinated global observations highlight the intensity of interest in this interstellar visitor. Every new image and every new data point has refined our understanding of its composition, trajectory, and behavior. However, the most tantalizing questions persist, especially concerning its anomalous acceleration and the intriguing coincidences surrounding its approach to Jupiter and the WOW signal from 1977 as the comet continues its journey through the solar system, passing close to Jupiter in March 2026 and continuing its long path outward. We remain watchful. What secrets will this ancient traveler reveal as it passes by? And how will it reshape our understanding of the cosmos? Only time and careful observation will provide the answers. As 3I Atlas made its way through the inner solar system, its journey continued to captivate the scientific community. Even NASA's Lucy mission, which is on its way to study the Trojan asteroids that share Jupiter's orbit, contributed valuable observations. While the comet appeared as a faint smudge in Lucy's images 240 million miles away, each data point was crucial in refining our understanding of its trajectory and behavior. Solar observatories also joined the effort, tracking the comet's approach to perihelion in late October. NASA's STEREO mission, which observes solar activity from two spacecraft orbiting the Sun, captured images of 3I Atlas passing through the inner solar system, while the Punch mission, designed to study the solar wind, recorded the comet's activity from September 28th to October 10th. These observations showed how solar wind and radiation pressure were shaping the materials streaming from the comet's nucleus. One of the most dramatic observations came from NASA's SOHO mission. Positioned at the L1 Lagrange point between Earth and the Sun, although scientists initially thought the comet might be too faint for detection, careful processing of multiple images revealed 3I Atlas as a faint streak against the solar corona, a brief visitor from another star silhouetted against the Sun. The coordination of these global observations, ground telescopes, space telescopes, Mars orbiters, interplanetary probes, and solar observatories represented an unprecedented effort to study an interstellar object. Europa Clipper also contributed observations, providing details about 3I Atlas's composition and outgassing from its unique sunward vantage point. This wealth of data confirmed that 3I Atlas was unquestionably a comet, with a nucleus, a coma, and tails. It outgassed water, carbon dioxide, carbon monoxide, and other volatiles, and it brightened as it approached the Sun, only to fade as it receded. However, the comet displayed some unusual characteristics that make it unlike any other comet observed in our solar system, with anomalies that scientists have yet to fully explain. The most notable of these anomalies is the anti-tail, a sunward jet that persisted from early observations and continued to puzzle astronomers. While typical comets have tails that point away from the Sun due to solar radiation pressure, 3I Atlas has a tightly focused jet extending toward the Sun. Various hypotheses have been proposed, including the scattering of sunlight by tiny ice fragments or the presence of objects lagging behind the comet due to non-gravitational acceleration. Another mystery lies in the comet's unusual polarization, which is unlike any known comet and suggests that the dust particles in 3I Atlas might have unique shapes, compositions, or size distributions. Additionally, 3I Atlas's chemical composition has raised eyebrows. It contains an unusually high amount of nickel relative to iron, an anomaly that some scientists, such as Avi Low, have suggested might indicate artificial processing. While mainstream astronomers are cautious about such claims, the nickel-to-iron ratio and other peculiar chemical features continue to spark debate. Beyond the comet's chemistry, its trajectory has also been a subject of intrigue. 3I Atlas's orbit was aligned with the ecliptic plane to within just 5 degrees, an extremely unlikely configuration for an interstellar object, with a probability of only 0. Bifinger R. Its close approach to Mars and the unusual timing of its passage through the inner solar system only added to the sense that something extraordinary might be at play. Yet, despite all these anomalies, 3I Atlas has behaved as a comet should. It has not fragmented unexpectedly, nor has it exhibited any actions that defy the laws of physics. During its flyby of Mars, it was closely observed by Mars orbiters, rovers, and even interplanetary probes, but it did not display any behavior that would indicate it was anything other than a natural body. The notion that 3I Atlas might be an alien probe has been speculated, particularly because of its trajectory alignment with the 1977 WOW signal, a radio signal detected by the Big Ear radio telescope. However, despite some intriguing coincidences, like the fact that 3I Atlas was approaching the solar system from the same direction as the WOW signal, scientists remain divided. The signal, which lasted for 72 seconds, has never been detected again, and no conclusive evidence has connected it to 3I Atlas. Some suggest that the signal might have been a targeted communication aimed at a specific location, such as Earth's position at the time. In late September 2025, Avi Low published calculations showing that 3I Atlas passed through the area of the sky where the WOW signal originated. the alignment was only 9 degrees off, with a probability of 0. While this is intriguing, the lack of any recurring signal from 3I Atlas has raised doubts about the connection. The object continues its journey, with no signs of emitting artificial transmissions, but the link to the WOW signal remains tantalizingly speculative. Despite the challenges in interpreting these anomalies, the scientific community continues to monitor 3I Atlas closely. In October 2025, the Meerkat radio telescope in South Africa detected a natural radio signal from the comet, hydroxyl molecules created when water is broken down by solar radiation. While this confirmed 3I Atlas was outgassing, it also dashed hopes for detecting an artificial signal. This observation, however, revived interest in the WOW signal hypothesis, as scientists planned further research to explore the potential connection between the two phenomena. As 3I Atlas nears Jupiter in March 2026, it will continue to provide valuable data. While many of the anomalies remain unresolved, they have already sparked a deeper conversation about the nature of interstellar objects and the potential for extraterrestrial intelligence. Regardless of its origins, 3I Atlas has certainly captured the imagination of the scientific community and the public, proving that the universe is far stranger and more mysterious than we ever imagined. As it sails outward, carrying with it the secrets of a distant past, we will continue to observe, study, and ask the questions that drive human curiosity. As 3I Atlas made its journey through the inner solar system, its ever-changing appearance continued to fascinate astronomers. Its color evolution from red to green to gold offered valuable clues about its composition and the processes taking place on its surface. Initially, the reddish hue of the comet was expected, given its likely age and the accumulation of cosmic radiation over billions of years. As the comet approached the Sun, however, it began to show signs of outgassing, a characteristic behavior of comets as they heat up. The red color in comets often indicates the presence of tholins, complex organic molecules formed by radiation, breaking down simple ices and gases over long periods. This fit with the theory that 3I Atlas had been exposed to intense cosmic ray bombardment during its long journey through interstellar space. However, by early September, amateur astronomers observing the comet from Namibia during a total lunar eclipse captured an unexpected transformation. The comet, which had been red, now appeared green, a color more typical of active comets. The green hue is primarily caused by the presence of diatomic carbon C2, which forms when solar radiation breaks down carbon-containing ices. These molecules briefly exist and emit a characteristic green glow. This change in color puzzled scientists, as earlier observations suggested that 3I Atlas was depleted in carbon chain molecules. One possibility is that the depletion was only skin deep, and as the comet approached the Sun, the heat began to shed its outer layers, revealing fresher, less processed material beneath. As 3I Atlas continued its journey toward perihelion, this green fluorescence became more pronounced. By late November, the Gemini North Telescope confirmed that the comet's green glow was consistent with diatomic carbon emission. The perihelion passage had driven intense outgassing, with the coma expanding and the tails stretching. The comet, which had previously shown a reddish hue, now displayed the characteristic green of an active comet. Yet, the story of 3I Atlas's color evolution didn't end there. By mid-December, just before its closest approach to Earth, observers reported that the comet had shifted again. The green glow had given way to a golden or yellowish tint. This golden color likely resulted from the changing composition of the materials being released as the comet cooled. Water, ice, carbon dioxide, and carbon monoxide sublimate at different temperatures, and as the comet receded from the Sun, the less volatile materials, like water ice, became more prominent in the coma, producing a golden hue. Another interpretation of the color shift raised more concerning implications. Some researchers speculated that the transition from red to green to gold might signal that the comet was running out of ice. If this were true, the comet could be transitioning from an active comet into a dormant asteroid. Its volatile ices largely depleted after billions of years of exposure to cosmic radiation. This is a common process for comets in the solar system, which slowly lose their volatile materials with each pass near the Sun. Eventually, they become dormant, indistinguishable from asteroids. For 3I Atlas, which had spent so much time in interstellar space, this ice depletion could have been accelerated. The cosmic ray processing it underwent during its long voyage would have already converted some of its ices into less volatile forms. The perihelion passage in tota cinder of Femogtive, which subjected the comet to intense thermal heating, may have been the final shock that exhausted its remaining volatile supply. While this theory remains speculative, the observed color changes were undeniably intriguing. However, not all scientists agreed on the interpretation of these changes. Some cautioned against overanalyzing the color variations. Comets are dynamic objects, and their appearances can fluctuate as they interact with the Sun and other elements in space. The color changes might be part of a natural, albeit unusual, progression in the comet's evolution. As 3I Atlas continues its journey out of the solar system, scientists will continue to monitor its behavior and gather data. Whether the comet is nearing the end of its active life, or whether it has more to reveal, remains uncertain. What is clear, however, is that 3I Atlas has provided a rare and valuable opportunity to study an ancient interstellar wanderer from beyond our solar system, an object that has carried with it the secrets of the cosmos for billions of years. The questions raised by its anomalies, its color changes, and its connection to past mysteries like the WOW signal will continue to fuel scientific inquiry for years to come. As humanity strives to understand the true nature of this extraordinary visitor from the stars, the X-ray observations of 3I Atlas offered some of the most revealing data yet, contributing crucial insights into the comet's behavior as it ventured through the inner solar system. When X-ray observatories like Japan's X-RISM and Europe's XMM Newton turned their instruments toward the comet, they unveiled an astonishingly detailed and previously unseen aspect of its nature. On November 26th to 28th, 2025, X-RISM conducted a 17-hour observation of 3I Atlas, using its X10 instrument, a soft X-ray imager. The resulting data revealed a diffuse halo of X-ray emissions stretching roughly 400 kilometers from the comet's nucleus, a distance approximately equivalent to the distance between Earth and the Moon. This glowing halo was not emitted by the comet itself, as comets are far too cold to produce X-rays thermally. Instead, the glow was due to a process known as charge exchange. Charge exchange occurs when high-energy ions in the solar wind, such as protons and electrons, collide with neutral gas molecules released by the comet. These ions, stripped of most of their electrons by the Sun's heat, seek to capture electrons from neutral molecules. The result of this violent process is that the ions and the neutral particles become excited, and as they settle back into their normal states, they release energy in the form of X-ray photons. This process, observed in many solar system comets, creates a characteristic X-ray glow that is tied to the interaction of the solar wind with the neutral gas of the comet's coma. The X-RISM observations confirmed that 3I Atlas was actively outgassing, releasing substantial amounts of neutral gas, primarily water vapor and its dissociation products. The extended X-ray halo traced the vast volume of space over which the solar wind interacted with the comet's coma, marking the extent of the comet's active region. This was a major finding, confirming the comet's continued activity, even as it moved further from the Sun. But the story didn't stop there. Just a week later, the European Space Agency's XMM Newton Observatory, one of the most powerful X-ray telescopes ever built, took its turn observing 3I Atlas, XMM Newton's EPIC camera, capable of detecting X-rays across a wide field of view, spent 20 hours observing the comet on December 3rd. This observation was conducted when 3I Atlas was around 1.9 astronomical units from the Sun, about 175 to 177 million miles from XMM Newton. Despite having passed perihelion weeks earlier, 3I Atlas still displayed significant X-ray emission, demonstrating that its outgassing was far from over. In XMM Newton's observations, the bright red spot in the center of the image marked the comet's nucleus, while the surrounding gradients of purple and blue indicated a decline in X-ray intensity as one moved away from the nucleus. The images revealed a striking contrast, with the bright X-ray emission from the comet's coma outlining the boundary between the comet's gas and the solar wind. Even as 3I Atlas moved farther from the Sun, the X-ray emission continued to be detectable, underscoring the comet's ongoing activity. The X-ray data from both XRISM and XMM Newton provided unprecedented insight into the comet's composition and interaction with its environment. It highlighted the dynamic and evolving nature of 3I Atlas as it made its way through the solar system. These observations not only revealed a deeper layer of cometary activity, but also showcased the valuable role of X-ray astronomy in studying distant, faint objects like interstellar comets. As 3I Atlas continues its journey, these observations may prove to be some of the most critical data in understanding its behavior and how such objects interact with their environments. The anti-tail of 3I Atlas, an extraordinary feature that points directly toward the Sun, has been a source of intense mystery and intrigue. It defies the conventional understanding of cometary behavior, where tails are supposed to stream away from the Sun due to the solar wind and radiation pressure. Instead, the anti-tail of 3I Atlas consistently pointed sunward, persistently and tightly columnated. Unlike the usual diffuse tails of other comets, this unusual feature first appeared in the Hubble Space Telescope images on July 21st, when the comet was still approaching the Sun from beyond Mars's orbit. At this point, 3I Atlas was nearly 3 astronomical units away from Earth, and the anti-tail was already visible. What made it peculiar was that anti-tails in solar system comets typically appear only as a geometric effect when Earth passes through the comet's orbital plane. These transient anti-tails are simply a perspective illusion, dependent on the viewer's position. However, 3I Atlas's anti-tail was not a fleeting phenomenon. It persisted through changing geometries, visible in multiple Hubble images taken on November 30th, when the comet was moving away from the Sun at nearly 2 astronomical units from Earth. This persistence of the anti-tail across such a wide range of observations suggests that something physical is at play, not just an optical effect. Even more puzzling was the structure of the anti-tail itself. Unlike the usual spread of gas and dust from a comet's nucleus, the anti-tail of 3I Atlas was narrow and tightly focused, extending for hundreds of thousands of kilometers from the comet. Normally, as gas and dust escape from a comet, they disperse and form a broad tail, but the anti-tail of 3I Atlas remained sharply confined, raising the possibility that some force or process was actively shaping and focusing the material. Astronomer Avi Lowe devoted significant attention to this mystery. He proposed that the anti-tail might consist of small ice particles shed from the sun-facing side of the comet's nucleus. These particles would sublimate before being pushed back by solar radiation pressure, creating a transient jet of material directed toward the Sun. Another possible explanation suggested that the anti-tail could result from a swarm of objects trailing behind the comet, influenced by its non-gravitational acceleration, a concept that has become central to the scientific debate surrounding 3I Atlas. The persistence of the anti-tail and its unusual narrowness continues to be one of the most puzzling aspects of this interstellar visitor. Despite the various hypotheses, the precise cause of this phenomenon remains unclear. It is yet another anomaly in a series of perplexing features that have set 3I Atlas apart from typical comets, making it a subject of intense study and debate in the scientific community. Whether the antitail is a sign of some underlying unknown process or just a unique manifestation of known cometary behavior, it adds to the growing list of mysteries that will continue to captivate astronomers as they study this ancient interstellar wanderer. In papers co-authored with Eric Keto, R.V. Lowe proposed an intriguing model for the antitail of 3I Atlas. He suggested that it could be composed of tiny ice particles shed from the sun-facing side of the comet, driven by asymmetric sublimation of surface ices. Here's how the model works when sunlight strikes the sun-facing side of a comet. It heats the surface, causing ices to sublimate into gas. This gas expands, carrying dust and small particles with it. The expansion occurs preferentially in a direction perpendicular to the surface toward the sun. Initially, these small particles are ejected toward the sun, propelled by the outflowing gas. However, solar radiation pressure pushes them back. For most particles, this pressure quickly reverses their motion, and they are swept into the traditional dust tail. But ice particles, due to their reflective and partially transparent nature, may behave differently. The radiation pressure on these particles could be significantly lower compared to rocky dust, allowing them to continue moving sunward for a longer time before being pushed back. These ice particles sublimate as they move closer to the sun, shrinking and eventually disappearing. This could create a transient sunward stream of ice particles that vanish before radiation pressure has the chance to push them back into the tail. According to Lowe's model, the antitail of 3I Atlas would consist of these continuously replenished ice particles, creating a steady-state feature sustained by ongoing sublimation and ejection. This model is plausible but difficult to confirm observationally, since individual ice particles cannot be imaged at such vast distances. The best scientists can do is observe the collective scattering of sunlight from the particles and compare it to model predictions. Another explanation for the antitail might be linked to the non-gravitational acceleration of 3I Atlas. If the comet is experiencing a push away from the sun, as suggested by JPL horizon data, then objects that separate from the nucleus may lag behind instead of streaming ahead. A swarm of fragments or debris ejected during an outburst could accumulate in the sunward direction, simply because the main body is accelerating away from them. This interpretation links the antitail to the broader mystery of the comet's anomalous motion. The same force pushing 3I Atlas away from the sun could cause ejected material to lag behind, thus creating the sunward tail. In December 2025, new observations added another layer to the mystery. A paper analyzing images from July and August reported periodic wobbles in the antitail jet, suggesting a link to the rotation of the nucleus. The data indicated that the position angle of the antitail oscillated with a period of approximately 74 hours, with a margin of about 20 minutes. This periodicity implies that the jet source is not centered on the rotation axis, but is offset by some angle. As the nucleus rotates, the jet precesses around a cone, causing the observed position angle to wobble. The amplitude of this wobble was small, only about 8 degrees, meaning the jet base is located very close to the rotation pole, offset by less than 8 degrees. Such a geometry has fascinating implications. If the jet originates from a pocket of ice near one of the comet's rotation poles, that pocket would receive continuous sunlight as long as the rotation axis remains aligned with the sunward direction. This alignment would allow the ice to sublimate continuously, as opposed to intermittently. This could explain the persistence and intensity of the antitail jet. However, why would the rotation axis be aligned with the sun at large distances from the sun, where 3I Atlas spent most of its approach? The object would have had a nearly fixed orientation between its day side and night side. One hemisphere would face perpetual sunlight, while the other remained in perpetual darkness. The apparent motion of the Sun across the comet's sky would be slow compared to the rotation period, especially at several astronomical units away. For the jet to maintain its sunward orientation throughout the approach, the rotation axis would need to point approximately toward the Sun. The probability of such an alignment occurring randomly is around 0, adding yet another low probability coincidence to the list. After perihelion, the situation becomes more complex. The gravitational deflection at perihelion altered the comet's trajectory by about 16 degrees. The Sun's position relative to the comet shifted accordingly. If the rotation axis remained fixed in space, the alignment with the Sun should have been disrupted. Yet, observations in December showed that the anti-tailjet persisted, still pointing approximately toward the Sun. This suggests that either the rotation axis shifted to track the Sun, requiring some torque mechanism, or that the jet emerged from a new source location after perihelion. Lowe noted this as an additional anomaly. Before perihelion, the anti-tail was produced by a jet base near one of the poles. After perihelion, a jet base near the opposite pole would be needed to maintain the sunward orientation. This implies two pockets of ice near the poles of the nucleus, both positioned close to the rotation axis, capable of producing tightly collimated jets. Such a configuration is geometrically rare, adding another improbability to the growing list of anomalies. Mainstream planetary scientists have offered alternative explanations, focusing on the complex physics of cometary outgassing. Jets are common features of active comets, and their orientations can be influenced by surface topography, the distribution of ice, and shadowing effects. The sunward direction of the antitail might be due to projection effects or the specific geometry of the comet's nucleus. Steve Desch from Arizona State University has argued that Lowe's calculations are flawed, claiming that the antitail can be explained by standard cometary physics without invoking exotic explanations. The dust in the tail responds to radiation pressure in ways that could produce sunward features under certain conditions. Despite the differing opinions, it is universally acknowledged that 3I Atlas displays unusual jet activity that has captivated scientists and observers alike. The antitail has become one of the most visually striking features of the comet, giving it a distinctive appearance compared to the classic comet with a single tail streaming away from the Sun. Instead, 3I Atlas often appears to have multiple structures: a conventional dust tail, a plasma tail pointing away from the Sun, and the mysterious anti-tail pointing toward our star. Some images have shown the comet seemingly exhibiting spiral jets, reminiscent of the rotating beacon patterns seen in some active solar system comets. These spirals result from the combination of the comet's rotation and outgassing, with the jet sweeping through space as the nucleus turns. The physics behind cometary jets is complex, and many features that initially appear anomalous may have conventional explanations upon deeper analysis. 3I Atlas may eventually be categorized with comets whose peculiarities have explanations rooted in particle properties, viewing geometry, and outgassing dynamics factors we simply hadn't encountered before. However, the antitail might also represent something genuinely new, an outgassing behavior never before observed, because we've never studied such a large and active interstellar comet. Alternatively, as Lowe continues to suggest, the anomalous features could point to an artificial origin, a probe designed to look like a comet, yet displaying behaviors that defy natural cometary physics. The debate continues, and only further observations and analysis will reveal the true nature of 3I Atlas. The antitail of 3I Atlas remains one of the most enigmatic aspects of the object, reminding us that we don't yet fully comprehend the intricacies of such interstellar visitors. This mystery challenges our understanding of cometary physics, offering an opportunity for future scientists to investigate it further. While the antitail may not lead to immediate conclusions, it has certainly brought attention to cometary activity in ways that will benefit research for years to come. When 3I Atlas fades from view, the images and data captured will remain, waiting for future generations to analyze them with tools and techniques that we haven't yet developed. As for the ultimate nature of 3I Atlas, its trajectory continues to stir scientific debate. In March 2026, the comet will make its closest approach to Jupiter, and this event has sparked considerable interest. Jupiter, the massive gas giant at the heart of our solar system, exerts a powerful gravitational influence that can shape the orbits of objects within its reach. Its hill radius is approximately 53.5 million kilometers, essentially the boundary where Jupiter's gravity dominates over the Sun's. When scientists projected 3I Atlas's path toward Jupiter, they found that its closest approach would be within 53 million kilometers, virtually matching Jupiter's hill radius with an accuracy of 0.5, or about 1 inch 25. Ling ling ling. This extraordinary alignment has raised questions about whether it's just a remarkable coincidence or something more significant. Jupiter's hill radius has a unique property. Objects passing through this region can potentially be captured into orbit around the planet, with minimal energy required for station keeping. This means that if 3I Atlas were to release material as it passes through this region, the particles could be captured by Jupiter's gravity and possibly enter stable orbits. Specifically, at the hill radius, there are Lagrange points L1 and L2 where gravitational forces between Jupiter and the Sun balance out, and small nudges could keep objects in stable positions for extended periods. Avi Lowe has speculated that this might be more than a mere coincidence. If 3I Atlas were an artificial probe, it could be targeting Jupiter to deploy a long-term observation platform. Given the scientific interest in Jupiter and its moons, particularly Europa, which may harbor a subsurface ocean capable of supporting life, this hypothesis suggests that the comet's trajectory might be a deliberate path aimed at deploying instruments to study the Jovian system. If 3I Atlas is indeed an artificial object, its close approach to Jupiter could allow for long-term observations of the planet and its moons, with data being sent back to its makers or stored for future retrieval. This theory challenges conventional interpretations and suggests that we might be dealing with something far more complex than a natural comet. However, mainstream scientists continue to reject the idea of 3I Atlas being an artificial object, emphasizing that the anomalies might simply be due to the comet's unusual composition and the random nature of interstellar objects passing through our solar system. As the comet moves further out of the solar system, it will eventually fade from view, its mysteries becoming more elusive. However, the data collected during its journey will remain, potentially revealing more secrets in the future. Whether 3I Atlas is truly a natural object or a probe from another civilization, its passage through our solar system will undoubtedly leave an enduring mark on our understanding of interstellar objects. The possibility that it could be a technological artifact raises profound questions about life and intelligence beyond Earth, and the continuing study of 3I Atlas will likely inspire generations of scientists to come. This concluding passage encapsulates the fascination, mystery, and significance of 3I Atlas as an interstellar visitor to our solar system. While many questions remain unanswered, the comet has sparked intense scientific inquiry and inspired a sense of wonder. The anomalies surrounding the object continue to fuel speculation and debate, with some proposing that its behavior might point to something extraordinary. Yet, the mainstream scientific community remains cautious, offering natural explanations while acknowledging the complexities of cometary activity. As 3I Atlas moves further away from our solar system, the opportunity for direct observation will soon fade, leaving scientists to analyze the data collected in the coming years. While its trajectory and behavior might eventually be understood in conventional terms, the object serves as a reminder of the vastness of the universe and our place within it. The exploration of these cosmic anomalies offers a glimpse into the mysteries that continue to captivate humanity's imagination. Ultimately, the tale of 3I Atlas reminds us of the inherent uncertainty in science, where every new discovery leads to further questions. Even though the object will soon be beyond our reach, its journey through our solar system has left an indelible mark on the scientific community and will inspire future generations to continue exploring the unknown. The wonder of discovery, whether through the study of comets, stars, or distant galaxies, drives the human quest for knowledge and understanding, ensuring that the story of 3i Atlas is far from over.